Hello everyone, I'm Akash. Before getting started with the course, quickly take the pre-test. Hello everyone, welcome to the third and last module of e-learning course on power system protection. We have already covered the components of protection in the previous modules. We had discussed about relays in detail in the previous module. In this module, we will discuss a little more about relay setting. Let's get started. Let us take a look at the objectives of this course. By the end of this module, you will be able to discuss the parameters of protection relay, define some common terms related to protection relay, explain the pickup value in protection relay, explain the time setting option in protection relay, discuss how to select a curve in the time setting option. There are two broad categories of relay, namely electromagnetic induction and electronics. The setting procedure for both is also different. Generally, the following two parameters have to be set in each relay. Pickup value, that includes current, voltage, impedance, frequency, etc. and required operating time, which refers to the duration that is required for the connection to trip after exceeding the set point. However, before learning about these settings, there are a few more terms used in relay setting that you should know. Let us take a look. Here are a few more terminologies related to relay setting. Click on each tab to learn more. Operating force or torque. This is the force which tends to close the contacts of the relay. Restraining force or torque. This is the force which opposes the operating force or torque and tends to prevent the closure of relay contacts. Operating or pickup level refers to the value of current or voltage, which is the threshold above which the relay will close its contact. Dropout or reset level. refers to the value of current or voltage, which is the threshold value below which the relay will open its contact and return to normal position. Here is the formula for dropout level. Dropout by pickup is less than 1. Plug setting multiplier, PSM. PSM is equal to fault current by setting current. Time multiplier setting, TMS. TMS is equal to required operating time by normal operating time. Let us now look at how a pickup value is set in a relay. On the 50 by 51 overcurrent relay, the time overcurrent element or device 51 setting is made by means of a plug or screw inserted into the proper hole in a receptacle with a number of holes marked in CT secondary amperes by an adjustable calibrated lever or by some similar method. This selects one secondary current tap or the total number of taps depends on the relay on the pickup coil. Let us now understand with the help of an example. For example, assume that the CT has a ratio of 50 by 5 ampere. Typical taps will be 4, 5, 6, 7, 8, 10 and 16 ampere. The pickup settings would range from a primary current of 40 ampere or the 4 ampere tap to 160 ampere or the 16 ampere tap. If a 60 ampere pickup is desired, the 6 ampere tap is selected. If a pickup of more than 160 ampere or less than 40 ampere is required, it would be necessary to select a CT with a different ratio or in some cases a different relay with higher or lower tap settings. Time setting is broadly divided into two categories, that is, definite and inverse IDMT. These categories are denoted by different curves based on standardized equation given by IEC or IEEE. They are definite, inverse definite minimum time or IDMT, also called simple inverse, very inverse and extremely inverse. As you can see here in this formula, I to the power n into t is equal to k, where I stands for current, t stands for relay time, k is constant and n is a variable whose value starts from 0 and raises up to 8. Let us look at each of them in detail. The formula can be written like t equal to k divided by I to the power n, where n is a variable. Now, if we put n equal to 0, then it clearly shows that the time is equal to k, means time is constant for any amount of current. This is definite time curve. It is suitable for instantaneous operation. Now, let us look at simple inverse setting. If we put n equals to 1, then it clearly shows that an increase in the value of I will reduce the value of t, because t is equal to k by I. This is the beginning of inverse curve and is referred to as simple inverse. It is used where source impedance is less than line impedance and it is suitable for overcurrent and earth fault protection. Similarly, for very inverse, we put n equals to 2, and now the formula shows that the time inversely depends upon the square of current. So, as you can see, there has been further increase in the value of I. Therefore, the curve dips very fast with increase in current, which is known as very inverse. This curve is useful in thermal protection of transformer and motor and unbalanced protection of generator. Extremely inverse. As you can see here, the value of I has increased further, thus making the curve extremely inverse. This curve can be advantageous for coordinating HV fluids. Apart from these, there is another curve known as long time inverse curve. If the value of I increases further, for example A, it is referred to as rectifier protection relay. This is all about time setting. Next, we shall look at how to select a desired curve when setting time. In the time setting, the desired curve is selected by rotating a dial or moving a lever. The time dial should be between minimum and maximum values. At a time dial setting of 0, the relay contacts are closed. As the time dial setting is increased, the contact opening becomes greater, increasing relay operating time. Settings may be made between calibration points, if desired, and the applicable curve can be interpolated between the printed curves. We have learned a lot, and it's time now for a quick review. We have come to the end of the third and last module of Power Systems Protection. Here is a quick recap of the key points discussed in this module. In this module, we have learned that, generally, there are two parameters set in each relay: pickup value and required operating time, operating force, restraining force, operating level, dropout or reset level, plug setting multiplier, and time multiplier setting are few more terms associated with protection relay. The desired pickup value can be set by selecting an appropriate tab from the tab settings. Time settings are broadly divided into two categories, that is, definite and inverse, IDMT. However, these two categories are denoted by different curves. They are definite, inverse definite minimum time, IDMT, or simple inverse, very inverse, and extremely inverse. In the time setting feature, we can select a desired curve by following a few steps. Thank you for your time. Hope you enjoyed learning. Click next to take the post test.